Hello, this is Engineering Economics 2373. Today we're going to talk about computations with compound interest. Previously we have seen that the formula that we can use for compound interest is the one that is shown in the screen right now, and this allows us to make computations for what the future will have as a value for the money. What I like to demonstrate now is what happens when we make use of this as compared to the simple interest first. And we have this table here in which we can see that based on the number of periods we're willing to wait, if we make an investment of $1,000 and we have an interest rate of 10% per period, then we would get $100 of interest in the first period, as we've seen in the previous video. And in both cases we would start with the $1,000, but then we will end up with $1,100, both for the simple interest and the compound interest. However, starting the second period, since we only make interest on the initial investment, which is $1,000, if we have a simple interest, then we would end up with $1,200. Compare that to when we use a compounded interest. Now it's the complete $1,100 are earning interest, and therefore 10% interest earned on that yields a final value of $1,210. Now this compounding process can happen in longer periods. At the beginning it's a very small amount. So for instance, if we have 1,300 at the end of the third period, we comparatively we will have $1,331. $31 may not seem like a large amount to even care for. However, when we consider the passage of time, that quantity could be overwhelmingly different. Say for instance, if you're willing to wait 10 years, at the end of 10 years with 10% interest, you would end up, in simple interest, you would end up with $2,000. Compare that to $2,593 if you decide to wait the same amount of time with an interest rate of 10% compounded. Now, if we extend that in even longer periods of time, then you can really grasp the real value of using compounded interest rates. Because look at what would happen at the end of, say for instance, 30 years. The first investment only gets $4,000. Compare that to $17,000 plus $449 if you decide to invest using compounded interest rate. In a more dramatic case, if you decide to wait up to 50 periods at 10%, you would end up with only $6,000. Compare that to $117,390.85. So this is the real power of using compounded interest rates. Now, from the rest of the course, we will continue exclusively with compounded interest rates. Okay, so the formulas that we have right now will be in the screen, will be the ones that we will be using. Notice that we have a future value here, and that can be computed as a function of what we know about the present value, which is denoted by letter P. And in the compound interest rate, we have 1 plus I to the n as a factor that would allow us to compute a future value if we knew the present value. Therefore, 1 plus I to the n. It's also use a short notation for that would be we want the factor allow us to find the future if we know the present, we know the interest rate, and the number of periods. Conversely, we can find a present value if we knew a future value and we have a factor. Of course, by simple algebra, this factor becomes now 1 over 1 plus I to the n. And that factor that allows us to compute a future value if we knew a present value if we knew a future value, which is this factor, can be written for short as P given F IN. That is, the factor allows us to find the present value if we knew the future value INN. Now those are just factors. We still need to multiply them by either the future value or the present value. And that's the formulas that we will be using. Now we can use these formulas to solve all kinds of problems. Let's say, for instance, that you want to know how much money you will have certain periods from now, like the examples that we had before. Let's say that we want to compute the following. We're interested in finding a future value and we know the present value and we know the interest rate and the number of periods. That's the formula that we will use. If the present value is 1,000 and the interest rate is 10%, we write 0.1, and let's say that we have 30 periods, 30 years. If the interest rate is 10% per year, then that would be the equation for obtaining this future value. This future value will become, we need to do this computation. We can use the calculator to do this computation. It's very simple in this case, and most computations with a compound interest rate and only one cash flow would be very easy. So we have 1.1 raised to the 30th power, and that is, the answer to that is well, we would have $1,000 times 17.44940. And there are more digits, but let's cut it in the fifth digit right there. So the future value is going to be $17,449.40. And that's how much we would have at the end of 30 periods. How much we would have at the end of say 50 years. That would be future value, say at t equals 50. This previous one was at the end of 30 periods. The future value at 50 years would be again $1,000 times 1 plus 0.10 to the 50. Let's do that computation, and now we have 1.1 raised to the 50 is 117 390 point, I'm sorry, 117.390.85.29 and this becomes $117,390, and if we round it, 85 cents. And that's exactly the same answer that we got in the table at the beginning of this video.